Calculus 6.5a. What is the work done in lifting a 50-pound bag 5 feet? Work equals force times displacement. Work equals 50 pounds times 5 feet equals 250 pounds times foot. Object moving along the x-axis is acted on by a force Fx equals x to the fourth power plus 2x squared. Find the total work done by the force in moving the object from x equals 1 centimeter to x equals 2 centimeters. Distance is in centimeters, so force is in dynes. Work equals integral Fx dx equals integral 1 to 2 x to the fourth power plus 2x squared dx equals 163 over 15. It takes 4 erg of work to stretch a spring 10 centimeters beyond its natural length. How much more work is needed to stretch it 4 centimeters further? Hooke's law, 1/2 k L squared. 4 equals 1/2 k times 0.1 meters squared. 8 equals k times 0.1 meters squared. K equals 800 newtons per meter. Work equals 1/8 800 newtons per meter times 0.14 meters squared equals 7.84. 7.84 minus 4 ergs equals 3.84 erg. Spring whose natural length is 10 centimeters exerts a force of 30 newtons when stretched to a length of 15 centimeters. 15 centimeters minus 10 centimeters equals 0.05 meters. K equals 30 newtons divided by 0.05 meters equals 600 newtons per meter. Determine the work in stretching the spring 7 centimeters beyond its natural length. Work equals 1/2 600 newtons per meter times 0.07 meters squared equals 1.47. The force F required to compress a spring by a distance x meters is given by F equals 8x newtons. Find the work done in compressing the spring from x equals 1 to x equals 2. Work done. Work equals F dx equals integral 1 to 2 8x dx equals 4x squared 1 to 2 equals 4 times 2 squared minus 4 times 1 squared equals 12 newtons meter. The force F required to compress a spring by a distance x meters is given by F equals 8x newtons. It will be more work to compress from 5 to 6 than from 0 to 1. Find work done in compressing the spring from x equals 0 to x equals 1. Integral 0 to 1 8x dx equals 4 newtons meter. X equals 5 to x equals 6. Integral 5 to 6 8x dx equals 44. How much work is required to lift a 500 kilogram satellite to an altitude of 3×10⁶ meters above the Earth? F equals gm times m divided by r squared, where capital M is the mass of Earth, which equals 6×10⁴ kilograms. G is the gravitational constant, 6.67 10⁻11. Work equals integral F dr. Integral F dr equals integral G capital M times M divided by r squared dr. Work equals capital G times capital M times M integral 6.4 10⁶ to 9.4 10⁶ r negative to the negative 2 dr. Capital G times capital M times M is r minus 1 divided by negative 1 to 6.4 10⁶, 9.4 10⁶. Negative gmm times 1 over 9.4 10⁶ minus 1 over 6.4 10⁶ equals negative 6.67 10⁻11 times 6 10⁻24 times 500 times negative 4.986702 10⁻8, which gives us 9.978391 10⁹ joules. Rectangular swimming pool, 70 feet long, 15 feet wide, and 12 feet deep, is filled with water to a depth of 9 feet. Use integral to find the work required to pump all the water out over the top. Density of water is equal to 62.4 pounds per cubic foot. Volume of water equals 9,450 cubic feet. dV equals 70 times 15 dx equals 1,050 dx. F due to H2O equals 1,050 times 62.4 dx equals 65,520. dW equals F times 12 minus X equals 6,520 times 12 minus X dx, which equals 65,520 integral 0 to 9, 12 minus X dx equals 65,520 times 12x minus 1/2 x squared 0 to 9, which equals 108 minus 40.5 times 65,520 equals 4,422,600 feet times pound. A fuel tank is an upright cylinder buried so its circular top is 14 feet beneath ground level. The tank has a radius of 5 feet and is 15 feet high. Current oil level is only 11 feet deep. Calculate work required to pump all of the oil to surface. Density of oil equals 50 pounds per cubic foot. Area equals pi r squared equals pi 5 squared equals 25 pi. Volume equals 25 pi dx. Weight equals 25 pi times 50 dx equals 1,250 pi dx. Work equals 1,250 pi integral 0 to 11, 29 minus x dx equals 1,250 pi times 29x minus 1/2 x squared 0 to 11, which equals 1,250 pi times 29 times 11 minus 1/2 11 squared equals 323,125 pi.